Hi friends, welcome back in the series of recommendation system. So last time we had seen the popularity based recommendation system. As I told you that popularity means anything that is in trend, like, right, or for example popular name, popular mobiles, etc. Now we have today is the content based recommendation system. So content based is another type of recommendation system. So it is similar item based on a particular item, right? That is what content based defined. Okay, for example, if a person likes a particular items, right, so he or she also like an item that is similar to it. For example, the completely YouTube algorithm. If you like a video, so it is possible that you will like a video of same content, right? So that comes into content based recommendation system. So basically the content based recommendation system do not require a lot of user data, right? So let's see how it works. So again, for the first thing, we import the libraries like NumPy, Pandas. Then we are importing the cosine similarity. Again, what the cosine similarity is, it is the cosine of the angle between two vectors a and b, right? We will see the uses of it in the below content, right? Secondly, we are importing the count vectorizer from sklearn.featureextraction.text, and we are setting the options like display.max column. We are passing as 100, right? Now we have a CSV. So although I'll provide the link in the description, that is rs2 content based recommendation.csv, and there is also a link where you can get the CSV, right, directly. If we print the head, so this is what our data set looks like. So we have title, year, so again it is on movies. Okay, so released, runtime, genre of the movie, director, writer, actor, and all the necessary things are mentioned in this movie data set, right? Now if we get the shape, so we have 250 by 38, and if we get the df.title, genre, director, actor, and plot, so we'll be working on this data frame basically. So if we print the head, so here top 5 values are, you can see title, if the movie is The Godfather, right? So the genre is crime and drama, of course. Director is Francis Ford Coppola. Okay, actor are, these are the actor, Marlon Brando, okay, Marlon Brando and all these. And plot, so here the aging patriarch of an organization crime. So there is a short crisp summary about the movie. So now discarding the commas between the actor's full name and getting only the first name. So here you can see the actor's name, right? These are comma values. Now what we will do is we will get them like this. So df actor equals df actor dot map. We are using lambda x dot split from this comma symbol, and we are taking we are taking only first 3 values, right? So if we see in the very first example, so you can see that we have only the first 3 actor name. So these are the first 3 actor name, and rest will be kept away. So on so forth, we'll get a list of these actors. Now putting the genre in a list of words. So df genre equals df genre dot map lambda x dot lower dot split into comma. So here you can see that we are putting the genre in a list of words. So here crime, drama, I mean the 0th position movie, that is what, that is the Shawshank Redemption, right? So here you can see that it is crime and drama. So if we check it, so this is crime and drama. So we are having this list then. Okay, so see how we are framing this content based recommendation stepwise, step by step, so that we'll get a better clarity on it. Next thing we have is, similarly we are doing for director. So here Frank and Darabont for again the 0th movie, and so on so forth. We are getting the list for it as well. Now for index row in df dot iter rows, right? So row actor equals to x dot lower, replace this space with comma. Okay, for x in row actors. Okay, then a row director equals to then we are joining, we are applying dot join row director dot lower. Okay, so here you can see that for 0 Tim Robbins, we already converted them all to the lower case. Then we have Tim Robbins. So if you check the 0th, we have Tim Robbins. So here you can see that we have converted that to lowercase, okay, to make it distinguished, right? Then we have the Morgan Freeman and Bob Gunton. This is the Morgan Freeman and Bob Gunton. So this way we got it, okay, and so on so forth for all the variables. Similarly we have done for director, so Frank Darabont, like this. So we have concatenated or joined the their two names. Now from Nick NLTK import rec, so initializing the new column. So here keywords equals to, we are defining it as blank. Now index row in df.iter rows, so plot equals to row plot. So here you can see that we are initializing rake. By default is uses English stop word from NLTK, and discard all punctuation characteristics. Although we will be learning this natural language toolkit in detail in the future videos, but for the sake of example in the content based recommendation system, here you can see that we are then dropping the plot columns, right? After doing all this extraction of the word by passing the text, then getting the dictionary with keyword and their scores, then assigning the keywords to the new column, right, and dropping the plot column. So here keywords dictate score. So here you can see that we got it. Now title in place equals to root, so we are setting the index as title. So now title is our index, right? So here you can see that we have the df. So the genre is listed like this, director are concatenated or joined the name like this, actor are joined like this, and similarly we have the keyword. And keyword, yes, as I said that this was the brief description about the movie. So we have separated all this single word by comma. Now bag of words, so column equals to df dot column, index row in df dot iter rows, word we are taking this for column in column. If column not equals to director, then words equals to word plus, again we are joining it. So here you can see that if we print by applying this function, so here for example the bag of word we are getting crime, drama, Frank Darabont, and that means we are getting all these into one bag of words: crime, drama, Frank Darabont, right, then Tim Robbins, this one, and so on so forth. Okay, then initiating the generating the count matrix. So we are using of course the count vectorizer. Now count matrix equal to count dot fit transform df bag of words, creating a series for the movie title, so they are associated to an order numerical list. Will use later to match the indexes. So indices equals to pd dot series df dot index, right? So indices we are getting 0 to 4. So the shape so for 0 to 1 2 3, similarly you got all this title. Now count matrix, if we count it, so we got it like 250 by 2961 spare matrix of type this one with 5342 stored element in compressed spare row format. So basically we are like pre-processing our data first. So c equals to count matrix dot to dense. So now we are applying it to the dense matrix. So here you can see that if we print it, now type count matrix, if we print that, so we'll get scipy dot sparse dot csr matrix. And if we print the count matrix, so here what we'll get it. Now we can get the vocabulary from here. So for crime we have 584, drama 768, right? So Tim Robbins we have 2678. All right, now generating the cosine similarity matrix. So cosine similarity, again as I said that this is nothing but a cosine of the angle between two vector a and b. So here count matrix is our a, and again we are passing count matrix as b, so we'll get the cosine similarity for that. So this is what the cosine similarity is. Now function that takes in movie title as input and return the top 10 recommended movies according to that movie title. So this is what we'll get from the this all the pre-processing thing. Now recommendation. So this is how we can assume that our YouTube algorithm or Netflix algorithm, right, or anything that we want to sell, or we want to do some online marketing, so we can use easily the recommendation system. Now define recommendation. So title cosine similarity equals to cosine similarity. So we are getting these input parameter. So here basically we'll get the title because cosine similarity we already have. Now recommended movie. So this is our blank list, getting the index of the movie that matches the title. So idx indexes equals to title dot index 0, creating a series with the similarity scores in descending order. So this is the main thing that we have. Score series equal to pd dot series cosine similarity of this idx, right, sorting values in descending order. Now getting the indexes of the 10 most similar movies. So top 10 indexes list score series of ilog 1 to 11. That means it will give us 10 values, and dot index. So print top 10 index, populating the list with the title of the best 10 matching movies. So for I in top 10, so it will give recommended movie dot append list. So we'll returning this list at the last. So here if we pass the forgo movie, right, so what we will get is we will get these 10 recommended movie. One is 132, that is No Country for Old Men. 34, The Departed. 226, Rope. 1, The Godfather. So on so forth. And how we got it? So again, if just pause the video, if you have any confusion on it, please check it again. As I said that we made the keyword or we extracted the word from the description, like when we separated the description of the movie. So according on the basis of those keywords, so it is only the content based, because we have the content, then only we are processing the data, right? Similarly, indices equals to forgo index. If we get it, it is 128, sorry, 128 is forgo and the related movie that we have. Now pd dot series cosine similarity. So cosine similarity of indices equals to forgo and index 0. So this is what the cosine similarity of this movie, okay, with others. So this was all about this videos, friend. I hope you enjoyed it. If yes, please do like, share and subscribe. This was just an introductory video of the content based recommendation system. Although we'll come up with the detailed use cases or the project in the recommendation system, please do like, share and subscribe. That will motivate us to keep uploading videos, because our team is keep working on it, right, to make the content available on YouTube, so that you can easily get familiar with these topic in the domain of AI/ML. So till then, all the best. Let's meet in the next video. Thank you. Have a good time.